Morning, everybody. So we jumped ahead to chapter 8. We're going to talk about this topic, which is arrays and collections. And at the risk of sounding like a broken record, right? I always like to talk about why this is important. Why are arrays important? At the risk of sounding like a broken record, arrays are important because these are another fundamental building block for programming. Okay? Much like loops, much like if statements, you are going to find arrays in any programming language you study. Okay, whether you're studying Java, JavaScript, C Sharp, Ruby, Python, PHP, all these different languages have arrays because they're just a fundamental building block of coding. All these applications I can look at on my computer. I don't know the source code for PowerPoint. I don't know what PowerPoint source code looks like, but I can tell you there's arrays in them and or collections, right? Just because they're just that foundational, okay, to code. So again, at the risk of sounding like a broken record, these things called arrays are critically important. So let's talk about what they are, what are arrays, how to work with them, and why they're important. All right, I'm going to make a little GUI here, and we'll put this inside of the Chapter 8 folder. Solution name Chapter 8, Demo 1. So what are arrays and why are they beneficial? Arrays are ways to store information. And you might say, wait a minute, I thought variables store information. Well, that's correct. A variable stores a single piece of information. For example, first name. Okay, first name could be stored in a variable. And if I do a little button click and a text box, we'll just, and a label. And okay, let's do label result. And this will just say button submit. And a little click. Let's see, click me. Okay. And this will be, text first name. Well, when you're working with like one person or two people or three people, you could say person 1 name first name, person 2 first name, person 3 first name, person 4 first name. And that's tolerable. It's not too bad, right? To have a single first name in a single variable. And you guys have done labs like this, right? You've done things like this, right? So this is like real, like, okay, we understand what a variable is. We understand that a variable stores a single piece of information, and that's cool. But what if you had, like at Rankin roughly has 2,000 students. You want to put 2,000 variables? String person 1,876. First, you see where I'm going with this? basically, if we keep following this syntax, we're going to have 2,000 lines of code just to put data into our variables, right? So a variable stores a single piece of information. And that's okay if you're not working with a lot of information. Okay? But arrays are more like storage containers. Like you think of a storage container. Does anyone rent a storage container? Like they got too much stuff and they got to rent a storage container and put all their stuff in the storage container? Is anyone's family? I know my brother had a storage container. You know what I'm talking about? Everyone knows. In America, we have too much stuff. Because we have too much stuff, we got to pay other people to hold our stuff. Like my family definitely has a little bit of that going on. And what I mean by storage containers can hold a lot of information. More than one piece. Right? So if I have an array of names, well, I could just have an array that holds 2,000 names. Right? I don't have to make 2,000 variables. I make one array, which is kind of technically a variable, but I make one array, and that one array can hold 2,000 first names. Okay? So a variable holds a single piece of information. An array is a storage unit, much like, what's the name of these companies that store, much like these storage companies that store all of our stuff. Okay? An array is a storage unit that can store all the information. Okay? So that's what an array is. That's how an array is useful. An array is meant to store a lot of information, more than just a single piece. Okay? It could be 10 pieces of information. It could be 5 pieces of information. It could be 1,000 pieces of information. Now, arrays have much like a variable. You declare and assign a variable. You declare and assign an array. All right, so if I'm just string first names, plural because it's multiple pieces of information, right? So when you're naming your array, now the brackets here, and I put the brackets over here. We're going to keep the brackets on the data type. Okay? Some languages you can put it in either place. C#, like if I look at the slide here, you notice the brackets go on the data type. Okay? So the brackets, these little symbols right here, you put them on the data type. That is your sign. It's like that old comedian Jeff Foxworthy. You guys remember that? Here's your sign. Whatever. This is your sign. The string. That this is an array. Okay. The array name is called first names. Equals new string, and again with the data type we're putting the brackets, and what goes in this set of brackets on the right hand, this is just the syntax for creating an array. I said we got 2,000 first names. You put the number right here. This number determines how big our storage unit is. This storage unit can store 2,000 strings. A lot easier to declare an array to store 2,000 pieces of strings, 2,000 strings. Okay? This is the syntax for declaring and initializing, right? Assigning and initializing, you can use those terms interchangeably. Remember, initialization is the first assignment. Okay, declaring and initializing an array. When you initialize it, you determine how big the storage unit is. In this case, the storage unit can hold 2,000 pieces of information. That's the first step. So why are arrays important? They're fundamental. They store data. Just like variables, they store lots of data. Variables store a single piece. Arrays store a lot. Okay? The first step of working with an array is to say how big is the storage unit. As if you were walking into the storage company and you say, hey, I got a lot of stuff. I need this big of a container. Okay, I need a small, a medium, or a large container. A large would be 2,000. Small might be 100. Medium might be, I don't know, I'm just making this up, but you get the idea, right? This is how many pieces of data. So let's just do a small storage unit. Let's just say 5 pieces of information. Okay, just for demonstration purposes. It's just as easy to make one that says 5,000. Okay, but just for demonstration purposes, we're going to do 5. So instead of having person 1 first name, person 2 first name, person 3 first name, we're just going to have one array that stores all 5 first names. So we no longer need to do this. Okay. I always feel like there's 3 steps. 3 steps. Well, I guess there's 4 steps. Step 1, declare and initialize. Step 2, put data into the array. Step 3, pull data out of the array to display on the screen. And, well, maybe step 3, maybe, could be the math, if there's math necessary. Okay? Because once you have once you have some numbers in the array, maybe you want to do some math on those numbers. Maybe, right? But just like we were doing before, what we were doing before? Input, math, output. Process is the same, very generically speaking. Put data into the program, do some math on that data, output what's important to the user. Input, math, output. So how do we put data into the array? You use these brackets and a number. Now before, the brackets were on the data type. Now, after you've declared and initialized the array, then you put the brackets on the identifier. Right? First names is our identifier. If you've got a storage unit, we know this storage unit can store 5, it has 5 compartments. Right? Each compartment stores a piece of information. So to put information into the first compartment of the array, you have to say put it in the first spot. The way that we do that is with the number 0. in computer science, we always start the count at 0. Okay? You might think that the first position would be position 1. Most people start their count at 1. It just makes sense. Us computer science people, we don't make sense. We start our count at 0. We're different. We want to be different. This is how we're different. First name sub 0 is Billy. First names sub 1 equals Tommy. First name sub 2, Jan. First name sub 3, Chris. First name sub 4, now, because we start our count at 0, notice that these numbers, these are our positions in the storage unit. Okay, in position 0, we're storing this information. In position 1, we're storing this information. So on and so forth. Okay, these numbers right here, by the way, are called the subscript. So the numbers inside the brackets are called the subscript or index. Commonly said as sub and then the number, sub 0 or sub 1 or sub 4. Okay, so when you hear me say first names sub 4, I'm talking about the first names array and the data stored in this 4th subscript. Okay? Part of the confusion is because we start our count at 0, this is still 5 pieces of information. 1, 2, 3, 4, and 5. Okay? So here's the rule of thumb. Subscripts start at 0 and go to 1 less than the number of total elements in the array. In this case, the total number of elements is 5. So 1 less than the total number of elements is 0 through 4. Those are the subscripts for this array. Right? So if I have 100 elements, my subscripts are 0 through 99. If I've got 1,000 elements, 0 through 999. Right? If I have 5 elements, my subscripts are 0 through 4. If I've got 8 elements, my subscripts are 0 through 7. Catching on? Subscripts are always 0 through 1 less than the number of elements. Now, some of you might be wondering, but Mr. G, you just said if we got 2,000 students, it would take 2,000 variables to put that in, 2,000 lines of code to put in all the names. And you don't want to put 2,000 lines of code to put in all the names. And here we are, and here we're doing basically the same thing. See, if we had 2,000 students, would we not have to write 2,000 lines of code to put in all the names? And if you wondered that, the answer is yes, that's not very efficient, is it? Is there a way, is there a coding structure that we learned that can do a repetitive task over and over and over? What is that structure? A loop. Who said that? All right. So very commonly, very commonly, to put data into the array, very commonly, loops are used to put data into an array. Why? Well, it simplifies the task. Check this out. If I do, was the original number was 2,000. Here's 2,000 first names. Okay, and I don't want to populate my first names like this. By the way, what are the subscripts here for my 2,000 first names? What are the subscripts? 0 through 1,999. Good. Instead of manually populating this like I was, let's use a loop. Let's use a loop. I'm going to use a for loop. Now watch, I hit for tab tab. And it code snippets, insert a little snippet of code for me. Notice I start my control variable at 0. That's an interesting place to start. What's our first index in an array? What's our first index in an array? What position is it? Position sub 0. So it's interesting that my code snippet starts my I off at 0. Because arrays start at 0. So we might be able to use this I inside of our array. Now, it also loops through less than something. What if I say less than 2,000? I would start off at 0, and it would loop 1, 2, 3, 4, 5. It would increase one at a time until I became 1,999. Is 1,999 less than 2,000? Yes, it is. It would run the body of the loop. I would go to 2,000. Is 2,000 less than 2,000? No. So it's done with the for loop. So what's really interesting about a for loop is that even when you use a code snippet, this is going to loop from 0 to 1,999. Isn't that really interesting? Because someone just told me that my subscripts are 0 through 1,999. So we're going to use I. Here's the part that kind of like screws people up. We are going to use, I even got an apostrophe we're going to use I as our subscript. Before we were using these numbers as our subscript. But what does I hold? I holds a number. I holds a number. So if I say first names sub I equal to Billy. What does this loop actually do? This loop takes all the 2,000 first names and inserts Billy in all 2,000 places. So there's at this school, whatever, there's 2,000 students, they're all named Billy. Makes no sense, but it does because I'm just trying to introduce these concepts, right? I'm trying to show you that we can use a loop to put data into an array using I, which we know is our control variable. I is our subscript that can be used to put data in. Now, in a real-world program, you'd probably be getting the student first names out of a database, Okay, so it'd be more complex than this. You'd have to read the first name and then put it into your array. Right? We would not have 2,000 students named Billy, but the process would be just the same. Declare an array, put in the information, and then output. Okay? Same thing. Could we label result.text equals first names sub-0, which, by the way, first names is a string. This is a string array. Right? This doesn't really do much. But you can see the label, if I store, this is student number 1,000, right? Because 0 through 999, this is the 1,000th student. That's also Billy. Doesn't really matter. Student 1999 is also Billy. You can see how you can use these different subscripts, right? And whatever, later, first names, oops, I didn't mean first name sub-0 was actually Tom, right? Just to show you that we can change, just like variables can change. At one point, the first name could be, one thing, and then you could change the variable to say something else, and then I output that something else. First name sub-0 is changed to Tom, and then I output Tom. Now, much like for loops are used to put data into the array, for loops can be used to pull data out of the array. Because again, we're trying to be efficient here. I could do 2,000, and I'll say label result.text, and what I'm going to do is I'm going to append first names sub I. Again, we're using I as the subscript. Use I as the subscript because I is changing every iteration through the loop. I is incrementing by 1. Good. There we go. Put in a new line, right? So this will be fun to watch. What's happening right now is it's running my loop and not responding because it's trying to output 2,000 names to the screen, and it's kind of choking on the processing of that. So maybe to demonstrate this, I should shrink my 2,000 names down to 10 names. I did not anticipate this. So it makes me wonder if I have an infinite loop, but I don't think I do. I think my problem is that 2,000 names is just a lot. So let's go back to my 5. Less than 5, less than 5. There it goes. All right, guys. Very basics of arrays, right? All I've done so far is covered what is an array, why is it useful, how common it is, how do you put data into arrays, how do you pull data out of arrays. And I covered this fairly quick. So here's just some reviews, okay? What does this number 5 mean? Let's just review this information. What does that number 5 mean? In Discord, feel free to chime in. On line 37. Adrian? How big the array is. Yes. Another way of saying that is the number of elements in the array. You could also, this is AKA, okay, you also hear this being called dimensioning an array. Essentially, as we're all saying the same thing in different ways. I think that's part of the challenge of learning to code. I could call this declaring and initializing my array. I could call this dimensioning my array. I could say determining the number of elements in my array. There's so many different ways of saying the same thing. How big the storage unit is. Could I store the number 10 inside of this first names array? What do you think? Do you think I could store the number 10 inside of this first names array? I got one on Discord that said absolutely not. I would agree. For example, watch what happens. First names sub 0 equals 10. Why not? It's an array of strings. And if you're going to store, so back to the point, your arrays have data types. The data types matter. Just like you couldn't store the number 10 inside of a string before. Now, could you store it inside of a string value 10? Okay, we can make this work, but keep in mind that if you were to do this, you cannot do math on a string 10. So if you wanted to add a number to it, you can't do that, right? To do math, you have to store it in a numeric data type like an int, so on and so forth. So don't let that confuse you. Just safe to say, you can't. Arrays have data types, and those data. You can have an array of ints. You can have an array of double. Okay? So your arrays do have data types, and those data types do matter. You could only store the appropriate data in those arrays if the data types match. Okay, you can't store a string inside of an int array or vice versa. String array of first names equals new string with 5 first names. Now, could I put 5 here and that's going to loop 0 through 4? Yes, I could. Let me show you something that's even a little bit better. First names dot length. First names dot length. The length property of an array holds the number of elements in the array. So how many elements are in this array? There's 5 elements. So this loop will loop I from 0 while I is less than 5. Why is that better? Because if I change this to 5,000, now this loops from 0 to 4,999 automatically. In other words, I don't have to change it in 2 places. Right? Because if I had 5 here before and then I had 5 here, okay, and all of a sudden I change this to 5,000, I also have to change this to 5,000. That's why you just go ahead and use the length instead, first names.length, and then when you change this, it automatically changes this. All right, we're just going to stick with our problem. This is going to loop 0 through 4. What is I the first time through the loop? What does I start off in the loop? 0. So the first time through the loop, what is this going to say? Please enter the name for employee number I plus 1. 0 plus 1, of course, is 1. So the first time through the loop, this will say, please enter the name for employee number 1. Does it make sense to the end user that we start our count at 0? No. The end user doesn't start their count at 0. It's just the silly programmers that start their count at 0. Right? So to the end user, we show them, please enter the name for employee number 1. We just add 1 to the I, and that just is always going to be a more standard count, because that's how we learn to count when we're taught to count, right? First names sub I equals console.readline. Remember, the console.readline lets the user type whatever they want. First name sub 0 is the first time through the loop. Then first name sub 1, then first name sub 2, then first name sub 3, then first name sub 4. It's going to go ahead and populate all the information. This is data in. Data's going in. First names.length. Console.writeline. Hello. First names sub I. So we're just going to say hello to each one of the, whoops. We didn't even do any math here. We just did data input, data output. Bob, Tim, Jan, Chris, Tim, Timmy too. Data goes in to the arrays, stores it, data comes back out. At the end of the day, this is just about storing more data than a single piece of data at a time. Double salaries equals new double. Each employee is going to have a salary. Please enter the salary for, check this out, because now that we have their name, we can use it. because the data goes into first name sub 0 here. We're going to use it right here. Please enter the salary for whoever they just typed. Salaries sub I. Again, the first time through the loop, that's salary sub 0, then salary sub 1, then salary sub 2, equals double dot parse console dot readline. Bob, 10,000. I got to output it. I forgot to output my salary. Bob, 10,000. Jan, 20,000. Chris, 30,000. $40,000, $50,000. Data in, data out. Trying to keep it incrementally following the process, one step at a time, adding complexity as we go. We're not done yet. All right. We are at a decent breaking point for a 15-minute break. So let's do that. I got 9 o'clock on my computer. Let's go ahead and take a break. Back from break, we're just jumping right into a demo here. Another way, if you know the numbers, if you know the values to insert into an array, you can use this shorthand All right, so what all this is a shorthand. This shorthand both declares and initializes the array and inserts values. So this would be accessed numbers sub 0 is 100. Numbers sub 0 is 100. Numbers sub 1, sub 2, sub 3, sub 4, sub 5. Sub 1, sub 2. There is no sub 5. This would break. This breaks. Let me show you what I mean by breaks. Oops. There is no sub 5 because it's 0 through 4, right? That's what we just learned. Unhandled exception. Index out of range exception. The index was outside the bounds of the array. The bounds are 0 through 4. The index was 5. The index was outside of the bounds of the array. Out of bounds. Right? In football, you went out of bounds. The index went out of bounds. It broke. So let's not do that. See? 1, 2, 3, 4, 5. So there are shorthands if you know their values. Okay? If you don't know their values, you got to get their values from the user. right? So let's say we don't know their values. We got the keyword new double 5. Let's input data into the array. 4. I equals to 0. If I hit tab, check that out. Like this. 4 tab tab. I hit tab a third time. Numbers dot length. We learned about this length property. What does it hold? What does the length property hold? Sorry? The number of elements in the array. How many elements are in this array? 5. So this is I starting at 0, while I is less than 5, aka 4. It'll loop 0 through 4, which are your subscripts for the array. Numbers sub I equals, actually console.writeLine. I'll do a console.write. Please enter number I plus 1. We add the 1 there so that it starts to count off at 1, not counting at 0. Please enter number 1. Please enter number 2. Please enter number 3. Or we'll say sale. Please enter sale number 1. Please enter sale number 2. Please enter sale number 3. Number sub I equals console.readLine. Of course, we've got a double on the left and a string on the right. You got to have your data types matching, so we're going to do double.parse. So if we run this, please enter sale number 1, 200, 300, 400, 50, and 60. Okay, we're not doing anything with that yet. But now we have an array full of numbers with data in them. Let's calc the sum, average, high, low stats. Kind of did this on a lab, right? We're going to loop through that same array again. Actually, let's put this. We don't need 2 for loops here. We can just put it. Yes, we do. We're going to get all the input first, and then we can calculate the stats. Now the sum, any value that increases each iteration of a loop is called an accumulator. It accumulates value. It gets bigger each iteration through the loop. Right? So sum is an accumulator because it just gets bigger each time through the loop. All right? Accumulators need to be initialized to 0. It's just a rule of programming. If you don't do that, we kind of come down here. This is numbers.length. If I don't do that, if I sum plus equals numbers sub I, this is going to error out. And it says use of unassigned local variable sum. Basically, the rule is you're gonna start an accumulator off at 0 every time, and that kind of like resets it back to 0. If you rerun the program a bunch of times, it could. If you don't do it, it could cause some data issues. Easiest to memorize. You got to set accumulators off at 0. All right, the first time through the loop, sum is increased by number sub I. The second time, which is number sub 0. Then it'll go up by number sub 1. Then it'll add number sub 2. Then it'll add number sub 3. All right. Now, for the highest value, there's something in C# called the min value property. Int.min value. We learned that an integer has a range. That range is, I want to say, was it billions on the high end? -3 billion to +3 billion, something like that. Okay? Int.min value is the smallest number that you can store in an int. So we're going to start off the highest value as that lowest possible number. Therefore, any number that they insert is most likely going to be bigger than the lowest possible value. So then you say if numbers sub 0 is greater than the highest, reassign the highest. Highest equals numbers sub I. Now, what do we got here? Double to an int. Let's just change these to doubles. So now we've got a double on the left and a double on the right. So if your numbers sub 0 is greater than your highest, then reassign highest. So the first time through the loop, whatever they type in is probably going to be a higher than highest. But each time it'll be comparing the next number against the current highest. It's really just the same thing. Double lowest equals double dot max value. And then you just change the if numbers sub I is less than the lowest, then you reassign lowest. Lowest equals numbers sub I. All right, so this is going to accumulate the sum, and it will check for highest and lowest. And then after the loop, we don't need to calc the average each time. We're just going to calc the average at the end. Calc the average at the end. Double average equals sum divided by numbers dot length. The sum, highest, lowest, average. $500,000, 2,000, 3,000, 10. Sum is 6510. The highest is 3,000. The lowest is 10. The average is 1302. Does that sound right? 500 plus 1,000 plus 2,000 plus 3,000 plus 10 divided by 5. Nope, that doesn't sound right. That sounds wrong. Average is 1302. Average is the sum divided by 5. All right, let's do the sum again. Maybe I did this wrong. 500 plus 1,000, might have been my calculator that was wrong. 2,000 plus 3,000 plus 10 divided by 5. Yeah, that's right. My calculator was wrong, not my program. Good catch. Okay, so if anyone's still struggling on the highest and lowest, we kind of, in the average problem, we just kind of did that one. Danny.
What about the methods for the array, like dot min, dot max?
Good. Yes. What about the methods that are built into the array? The short answer is that those methods work. So there are some built-in methods to do these same kinds of things, but believe it or not, they are not as efficient as doing the code yourself. So when you're looking at some of the built-in methods, they're inefficient compared to writing the code yourself. And I know that because you can put timers in C# and time the execution of this code versus the execution of the built-in properties and methods. And this one will complete faster based on the time. So they work, but I would prefer you use your own. So what are these, by the way? A series of steps to complete a task is called an algorithm. You might have heard of an algorithm before. An algorithm is a fancy word that basically says there's a series of steps to complete a task, right? The task at hand is to calculate the average and to calculate the sum and to find the highest and to find the lowest. So we wrote an algorithm. We wrote a series of steps to complete a task. Danny's question is, well, there's another way that it could be done. There's another algorithm that's kind of built in. Someone else wrote an algorithm versus this algorithm that we wrote. And all I'm saying is the algorithm that we wrote will perform a little bit faster than the algorithm that's built in to C#. Yes?
What when you above there when you have dot min value and dot max value?
Yes.
What those actually do?
This holds a very small value, like -3,900,000. It holds a very small number. The smallest number possible inside of the double data type.
So it's better to just say 0.
Why not just use 0?
No, so it's better than just using.
It is better than using 0. Because 0 could be a value. You could have 0. You could have 0. You could have negative sales one day, right?
Yeah.
What if one day you had one customer and they returned something? You had negative sales, right? So if you use 0 and you're testing to be less than 0, your lowest would not be accurate because your lowest would be 0, not negative number. Does that make sense?
Yeah.
Cool. Good question. Okay. The book goes into what are called they're called multi-dimensional arrays. You could call them rectangular arrays. In our labs, we really don't dive into these. Not to say we just don't get into these rectangular arrays. Rectangular arrays or multi-dimensional arrays are useful when you have related information. Think of it as like an Excel spreadsheet. All right. Here's why you might use a rectangular array. You might have, I always do sports teams, right? And so if we're dealing with data of sports teams, be it Major League Baseball, each column could represent a team, and each row could represent a position. So the team A, which would represent the Cardinals, the position 0, which would represent catcher, or position 1. So I know that Molina is the catcher for the Cardinals. Maybe B represents the Cubs, right? So the Cubs catcher, Wilson Contreras, I believe, is their catcher. C could be the Pirates. The Pirates catcher could be, anyone know the Pirates catcher? Google does. I don't know if this is accurate. Perez. The second row could be the first baseman. Goldschmidt, Paul Goldschmidt. Over there in the Cubbies, they got that all-star. I should know his name. I can picture him, but I can't. Rizzo? Is it Rizzo? It is Rizzo. Hey. Do you get where I'm going with this? So, an array that's rectangular has two positions. The first position represents the row. The second position represents the column. All right. Now, I'll just do a quick demo 3. If I were to actually build this one, I'm not going to get too in depth on this. A rectangular array has two sets. Yes, ma'am.
I just wanted to ask is lab 4 on the part 2 related to this?
Is lab 2 on
No,
part?
lab 4, the one with the timetable, and it asks for the column and the row. Is that related to this somehow?
I have to look at the lab. Let me look. Is it in the chapter 5 lab?
Yeah, chapter 5, part 2?
No, you should not have to do any arrays in chapter 5. Okay? Yeah, you should not have to do any arrays in chapter 5. So I'll have a two-dimensional array. What you do is you put a comma there. The first one represents the number of rows, and if our rows are our positions, maybe there's 10 positions. And the second one represents the number of columns. So let's just do 2 teams. Right? Then players, the 0 is the row. Remember, 0 represented our catchers. 0 represents the column. The second 0 represents the column, which represented the Cardinals. That was a test. That was a test of the emergency ranking system. It worked. We've got one other Cardinals, or we have one other baseball fan. Michael is a baseball fan. Let's see. Semicolon belongs on the outside. And you can begin to see now how to put data into a two-dimensional array. There's other ways of solving this programmatically besides using a two-dimensional array, but very simply put data in, put data out. quick demonstration of a rectangular array. Put data in, pull data out, that's all I did. Okay. What's nice about these is that within one array you could store even more information, rows and columns, if you will, worth of information. And they're all related because they're all National League Central players. National League Central Division players. Oh, by the way, that's not the right way to rename a variable. If we're going to rename a variable, let's just right-click and rename it. And we'll do NL Central. And you kind of see the benefit of renaming it that way. It renames it in all three places, as well as any additional places in the code behind. All right. A jagged array, as they mentioned here, has a different number of rows and columns. Like, it's not like a perfect square. Some rows might be longer than other rows. So that's what a jagged array means. So even these, like the array.sort, the book goes through and it shows you how to sort an array. So let's do this. Double numbers equals gibberish. There's an array class, array.sort, numbers, and I believe now if we output numbers sub I, now they're going to be in sorted order. So there is a nice built-in method to take these unsorted numbers. Because sorting is something that's so commonly done in applications, they've got this nice numbers.sort method that puts it in ascending order. Which is nice. There's also a binary search. So check this out. So there's a sort. A search, right? A search is exactly what it sounds like. You're looking for a piece of information. You're searching the numbers array for a value. Let's just say the value of 4. Now I think 4 is the smallest number. And it's going to return the index. Now keep in mind that these are sorted first. And then now we're looking for the value of 4 inside of the numbers array. And if it's found, it prints the index that it's found at. So do console.writeLine. Let me print out the index if it finds 4. Notice 4 is found at index 0 because it's sorted. Let me take this out. Notice 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 is in the 9th position. The 9th position is the 8th index because you start the count at 0. Oh, it didn't find it. Why didn't it find 4? Well, one of the secrets of a binary search is you have to have it in ascending order. That's the only way that it works. Binary searches only work if your data is in ascending order. Again, let me show you what it did. it printed out -1. -1 means it's not found. But if we bring that back, let's say we're looking for the number 12. 12's in the second position because 4 is first, 12 is next. So there's some very useful built-in methods. We can copy data from one array to a next. We're not going to use that a whole lot. They show that a little bit. Let's see. Yeah. This params keyword, we're not going to focus on this right now. We're going to learn what this keyword is probably in the next chapter or two. So don't stress out that params keyword for right now. Let's see. All right. There's one more important concept that is worth touching on in this chapter, and that's a list. Stacks and queues are also good, but we're going to focus on lists. Again, I like to take a short break every hour or so, or do. So let's take a 10-minute break. All right. One concept that we will need for the labs, a couple concepts for the labs in Chapter 8. Parallel arrays. Parallel arrays. All parallel arrays are two or more different arrays that subscript can be used together in parallel. We got 3 first names. We got 3 first names. We'll have 3 salaries. So what a parallel array means is that subscript 0, Tim, subscript 0 for salaries is Tim's salary. So 0 represents that person, right? Position 1 is Jan, and this is Jan's salary. Position 2 is Bob, and this is Bob's salary. So that's all it means when you have parallel arrays, is that just simply means it's very much like a rectangular array, rows and columns, but in this case you just have 2 separate arrays and their subscripts link them together. For I less than 3, this will say Tim's apostrophe yes, Tim's salary is salaries sub I. I'm forgetting something. Yes, I am. There it is. That's all a parallel array is. All right. So those are parallel array. Another concept for the lab is string.contains. Contains is a method. So I'm going to have a string of schools What are some of the high school you went to?
McKinley.
McKinley?
Yeah.
McKinley?
Yeah.
What other high schools do we go to in here?
Second.
Seckman? SECMAN? What other high schools do we go to in here? I went to Belleville West. McClure North. Is there a Parkway North? Okay. McClure South. We got competition. Okay. These are the schools, high schools. Okay. If string.contains it's not string.contains. If high schools sub 0, because it's a string, dot contains the word north. High school sub 0 is McKinley. It does not contain the word north. It is case sensitive, by the way, so if I put a capital N, that's different than a lowercase n. Else, high school sub 0, so of course that's going to doesn't contain the word north. Okay, let's change that to a capital N. But if I do 1 or 0, 1, 2, 3, if I change this to high school sub 3, high school sub 3 should contain the word north. Right? So string.contains is kind of a search inside of a string for a value. Now we could also say dot to lower. And then that way we're just comparing, it'll convert the word north to lowercase and then look for the word north in lowercase. That way you don't have to, no matter what, it's going to convert it to lower, and then you check it against lower. So that way it doesn't matter the capitalization. Now let's check this out. I'm going to rewrite this with the for loop. For, I'm going to loop through my high schools, dot length. I'm going to loop through all my high schools. And I'm going to write this. It is not permanent. No. No is the answer to your question. Just that's temporary. It's just for that line of code. If high schools sub I to lower dot contains north, then let's just print out the high school. Council.WriteLine, high schools sub I. So we're going to loop through all of our high schools, convert all of our names to lowercase, and then if it contains the word north, this is inside of an if statement, then we're going to print out the name of that high school. McClure North, Parkway North. Right? Maybe I say council.WriteLine. What school are you looking for? String school equals council.readLine. Here's our array of schools. Instead of plugging in the string north, I'm going to rename this to school search. My school search holds whatever the user is looking for. I'm going to replace the word north with the variable school search. It's getting cool. It's getting useful. Like something we would actually use. Even though it's a council. Right? Now, maybe I had a Belleville West. Belleville West. It's not finding it. So what do I do at this point? I'm going to insert a breakpoint. Yeah, no problem, Dylan. Let me debug this and then I'll. So school search holds the value Belleville West. We got my high schools. If high schools sub 0, which is McKinley, dot McKinley to lower, so that takes McKinley and converts it to a lowercase m on McKinley. So to lower just converts that value McKinley to all lowercase. Dot contains Belleville West. Oh, Belleville West was a capital B and a capital W. So I was converting Belleville West in the array to lowercase, but I was not converting my school search to lowercase. You see, school search still holds the value of Belleville West with a capital B and a capital W. So we need both of them to be lowercase. So we'll do school search dot to lower. We're converting the high school to lower, and we're converting the user's input to lowercase. Easy peasy debug. That's the magic of debugging. So now if I start without debugging, it doesn't really matter if I type, doesn't matter how I type it, it'll find Belleville West. You could say Belleville West was found. High schools sub I. Was found. All right, now here's the deal. If it goes through and finds it, I can't put an else right here. Let me show you why I can't put an else. Watch why I can't put an else. Was not found. Because every time through the loop, it's going to print one or the other. So you'll say McKinley was not found, Seckman was not found. I don't really care about these other schools. I just want to know whether Belleville West was found or not. So I can't really put an else right here, but what I can do, I can make a Boolean variable. Bool found equals false. Bool school found. We're going to assume that school found is not true. If it founds it, we'll set school found equal to true. And then if the school is still not found, if school found is not found, if you could read that as if the school is not found, school search was not found. So now I'll search for Belleville West. Belleville West was found. I don't know if do we have like an East? East was not found. One last thing. Contains will do a partial search. Like if I'm just looking for the word West, if it's found, if it contains that word at all, that will return true. Contains will return true. So like if I add in Belleville East, and now I'm just searching for Belleville, it'll find both Belleville East and Belleville West. Because contains does partial searches, you know. All right. I recorded this because these are help for your labs. And you can come back on the recorded video and rewatch this. Even though I do this fast, that's why I record it. To go, you know, you could rewind it on the video 10 times if it need be. All right. Winding down. By the way, you guys are going to need more lab time. I recognize that. I kind of hinted at that at the start of today. I didn't want to take 2/3 of today lecturing, but I am, because I'm taking so much time to lecture and go over this new material. You guys are just going to need more lab time. All right, so tomorrow what we'll do at the start of class, I'll update the syllabus. So make sure at the start of class tomorrow, you know, you're online and you'll kind of see the adjusted syllabus.
So we're not in person though?
No, we're in person tomorrow. We're in person.
So Wednesday becomes in person live day, with the plan.
Wednesday will probably be a remote lab day. Remote lab day. Yeah. Today, tomorrow in person, Wednesday remote, Thursday remote, probably Friday test. Okay? Arrays are great. Are the labs we do together on Chapter 8. The labs we do together. What do you mean, Parker?
Or you could be talking about like the naming conventions and one, I'm not sure.
Oh, the naming conventions and all those? Yeah. There's some of those for both chapters. There's naming conventions and all that. There's some of those for both. Yep. So we just, again, so that's going to be just like it always is. We just get those in when we have the time, is what that boils down to. There are not ones for Chapter 5, Part 2. Good observation. There's not a different set of Chapter 5, Part 2 ones, but there will be ones for Chapter 8. So, Parker, to go back to your question, the answer is yes. And to expand on that, there are not ones for Chapter 5, Part 2. There are not. If there are some in the PDF, we're just not going to do them. We get to a point where you kind of get the gist of it. I think you guys are getting the hang of it. So we're just going to focus more on labs. All right. We'll just do it once this chapter. All right. Attendance today is the written test. That is correct. If you turn in the written test by tomorrow, then it will count for your attendance today. You're good. Let me make sure that is the written test even active at this point? Chapter 8 written test?
No, it's not.
Okay, let me get that active for you. Chapter 8. This arrays material that we're going over right now? At the start of class.
So then when are the labs going to be due? Thursday then?
Thursday. So just so you guys know, I do not find any more enjoyment out of shifting the syllabus than you do. I promise you I don't enjoy this. I think part of what's happening is I'm having to slow down quite frequently because we're more remote than we're in person. I think this COVID remote work is slowing us down. At least this syllabus was perfect for last semester, which means this. Last year, we had 5 canceled school days because of COVID. So last year, there were 75 days in the semester instead of 80. So we get to slow down by the total of, if we lose, quote unquote, 5 days, we have that built into the syllabus. So the fact that we're slowing down a little bit, we've got the time to quote unquote lose, even though we're not losing because the majority of the class needs it to get the work done. Right? So that's kind of the big picture here. Let me get the test open tomorrow, due tomorrow. All right, Chapter 8 written test should be active. Am I recording all this? I am recording all this. Whoops. That's okay.
You always cut it out, right?
I could. Yeah. Test out my video editing skills.
So you said the test is going to be the attendance, or should we just push something to get just some?
I'm going to do the test for attendance because we're going to spend a little bit more time in lecture and then I'm going to say work on the written test for the rest of today. Okay? And then tomorrow and the next day could be our lab days. All right, folks, back to the lecture. Where we left off were these things called collections. All right. Arrays have some shortcomings, right? Arrays are not new to programming. Arrays have been around since the oldest of programming languages, okay? So in these newer languages, like C#, they came out with some new storage containers, right? You can think of arrays as kind of the old rusty storage containers, right? And now we've got these newer, there's climate controlled, there's bright lights around these storage containers. And so some of the rust, if you will, one thing that makes arrays a little bit rusty is that they're fixed in size. Okay, and what that means is they're fixed in size means once you dimension an array, like there's 1, 2, 3, 4, 5, 6 elements in this array, you cannot increase that. If you wanted to add schools, once this is dimensioned, you could not later on go high schools equals new high schools equals new string and say you got 10 schools. Whoop. Watch what happens if I try and increase the number of elements in the array. This is actually, it compiles. Okay, this compiles for each, boom, boom. Oh, I got to show you a for each. var item in high schools, console.writeLine item. For each is a shorthand for loop. It's a way to loop through each high school. And then each time through the loop, item, the first time through the loop, item holds McKinley. The second time through the loop, it holds Seckman. The next time it holds Belleville East. Okay, and this keyword var, we'll learn about that. But for now, you can just replace. For each string in high schools, write the high schools. Do you see? It printed out a bunch of nothing. Because I redimensioning arrays will cause data loss. That's a bad thing. That's bad. We put data into our array, then we redimensioned our array to hold more things, and then we lost all of our data. Okay? So there's ways around that. There are other solutions, right? This doesn't mean that we cannot redimension arrays. There are methods to, what you do is you make a bigger array, high schools 2, and then you copy the data from high schools into high schools 2. Okay? So there are other solutions, but this is some of the rust, if you will, that exists with arrays. So they make these things called collections that are these other storage units, these newer storage units that aren't so rusty, okay? And these are very commonly used. They're called lists, and they got these little brackets here. This is a list of strings called high schools equals new list of string. I'm getting my syntax wrong here. It's saying it doesn't know what a list is. in order to use list, you have to import this. Basically, you have to add this up here using collections generic, because list isn't recognized in your program unless you add this using statement up top. So now we have a list of high schools, right? But if I want to add an item to the list, I could just do highschools.add, and someone added a high school, McClure South. So let me add McClure South. And guess what? Now our high school list just got bigger. We redimensioned it to hold another thing, and we didn't lose all the data while we were doing it. So lists are great. Lists can have data types as a list of strings. They're very similar to arrays. They're just a little bit newer, a little bit shinier. Okay? And what we do is we use methods to insert data, to add new data. So these lists use methods, and let's take a look at some of those methods, right? So if I jump forward, the add method is to insert a new piece of information. So as I just did, we used add. And then you can access the list through their subscript almost just like it's an array. So let me show you council.writeline high schools sub 1 or sub 0. Of course, high school sub 0 should be McKinley. Debug, start without debugging. It prints out McKinley. Because we're not really searching for anything right now. So what are we doing here? Data input, data output. Data input with list, data output with list. So quite honestly, lists are a little bit easier to use than arrays. However, you got to know arrays. You're not going to be a programmer without understanding arrays. So arrays are still used. Arrays are still found in the real world. Okay, lists are just a little bit newer, so a little bit nicer, a little bit easier to learn. So we insert new items using add. We print them out just using a subscript, just like an array. Here they've got a list of strings, a list of decimals, right? They can dimension it, so they automatically grow and shrink. Like you don't have to worry about their size. They just automatically grow and shrink. You can dimension them as they do in this third one, right? The length property. Remember, the length property for an array is the number of elements in the array. The equivalent in a list is called the count. The count is what we use in our for loop to loop through high schools sub count. And then we print out high schools sub I. And that's going to print out even McClure South that got added. So count is the equivalent of length inside of your array. Right. There are other collections. There are other types of storage containers besides lists. They all use methods. For example, the queue in the stack. Okay? Queue in the stack. Here's the easiest way. You'll always remember stack. You know, with lists, you can put things in any position. A stack is, think of like a stack of papers. You can have when you put a stack of papers down on the table, you know, you put one paper down, so the first one in, the first one on the stack is the last one out. So if I take 10 pieces of paper and I put 10 pieces of paper down, the first one in, it's a stack of paper, right? First one in, if I'm going to take them back out, I got to start from the top of the stack. So the first one in, last one out. Right? So that's a stack of paper. And that's how, if you add things one at a time, they kind of get stacked on top of one another. And so when you go to access them out of the stack, they access them out from the top of the stack, one at a time. Okay? So they go in, and then the way they come out is from the top of the stack. Right? So stack, yes, first in, last out equals stack. Think of a stack of papers. First in, first out equals the queue. First in, first out, I think of like anyone ever work at a gas station? Work at a gas station, you fill the soda from the back of the freezer, right? The first soda in is the first soda out from the customer's point of view. So these are ways when you put data into a stack, they get added in a certain way, and when you pull data off of the stack, they get pulled out a certain way. And why does all this matter? Because some of these are more efficient for certain real-life scenarios. Depending on the problem you're trying to solve, your program might run faster if you put something in a stack or in a queue instead of putting it in a list. Okay, so some of these storage containers are quicker than the others depending on the problem that you're trying to solve. Yes?
You know what dictionary does?
Yes, what is dictionary? Is dictionary in here? Is dictionary in the chapter, or is that just something so dictionary is, I don't recall that being in the, dictionary is a collection, but you typically have a key value and then the actual value. So a dictionary, you can access a value by its key. Does that make sense? So there's two important pieces of information in a dictionary, is a key and a value. And so you might want to look something up by its key, and it's faster to look it up by its key than look it up by its value. So let me see if I can give an example of a dictionary. You see, when I have a dictionary, we have a key, and maybe the key is an int, and the value is a string called schools equals new dictionary int string. Now we're going to have to import something here. Nope, it already came in. Schools.add school, I don't know, maybe McKinley can be looked up by some school code. So the McKinley school code is, and then the code, Okay? So let's see. Then you look up school sub 556677. And that'll print out McKinley. So you use the key as the search value.
So
Yes.
would a key be like unique to each?
Yes. Yes. A key would be unique to each school. So this is what you're looking for. You're looking for school number 556677, and that returns McKinley. Does that answer your question, Danny? Yeah, dictionaries are useful. Good question. Awesome. All right. Any class, any day of the week, 3 hours of lecture or 2.5 hours of lecture is a lot, right? If you feel like overload, you're not alone. Okay? This is recorded. This is going to be put on YouTube. You can re-reference it, right, at a later time. It's a lot of new information. All right? I'm going to stop the recording here. We've covered a ton of new information.